So I guess I'll say it one more time. The first one, 1A, I think was hopefully something that was like straightforward, something like we've had in the notes at least. Part B, if this X minus 1 is tripping you up, it is something completely new and something they just threw at us. It is a bit weird. And I'm not expecting you to know that for the test. If you're able to like pick out the slope and say, hey, that other thing is probably like the starting point, that's the more important thing. Like, can you pick out a slope when they give you some words? Can you pick out the intercept or the starting point? Do you know that the slope goes with the variable? The intercept doesn't go with the variable. It's the constant out there by itself. Those are the things I really want you to kind of know for the test. Okay.
Here our slope is 125 teacher, right? And the function it's like 125x plus 2.25. Yes.
Yes. Yes.
Thank you.
Or it should be times the x minus 1. So it should be the
Sorry?
1.25 times the x minus 1 plus the 2.25. And that's just because we're skipping past the...
Than 1?
Yeah, because it's only good for things with x greater than 1 or equal to 1. So we're skipping past that first mile, basically. And so they're throwing that in there. And it's kind of weird, and it's something new that they threw at us. What about 5? Who's on here? Alondra?
I actually didn't get to do that one yet because I came late.
Okay. Carson?
Yeah, you said number 5, right?
Yeah.
Okay, so for A, I got $520 in taxes.
Okay, so we have an income of $5,200. And so where am I plugging that into?
The top one, the 10x, right?
This
Or,
is what I'm looking
yeah, right there.
Yeah. So we're looking first at where does this thing fall in? So this is an X value. They're telling us X equals what, 5,200 is what the problem's basically giving me. And so when my X is that value, they want to know what my Y or my, I guess, my T of X value is. And so this is piecewise. And so I think the main thing that people do is they just like try to throw it into like everything that's there. And it's like you just did 3 times this amount of work that you had to do. Don't do that. It only goes into one of these functions, right? And it's like it's restricted based on its domain. So we're looking at where does this 5,200 fall in? It falls in between 0 and 6,000. And so I'm plugging in 0.10 of what, 5,200?
Mhm.
And I think you said you're going to pay what, 520 in taxes?
Yes.
So I guess they're my equal sign here. This is what we're saying. Questions about that first part?
Okay, I have a question, but
Is that the solution or is there more?
So yeah, I guess I should maybe write it. This should actually say T of what, 5,200 was the number. Not text. Hitting the wrong thing, sorry. That should probably say actually T of 5,200 since that's the number that we plugged in, just like for the correct notation. But yeah, that's basically my solution. When I plug in that number, I'm going to get that number out of my T function.
So we don't need to figure out the other 2 variables or anything like that?
No, that's it. It's restricted by its domain, so we only plug it into the one where the domain fits, or where it fits in the domain.
Okay, so like the 48,000, it fits in between the 26 and the 63. So are we using the function that's on the other side to find out the answer for it?
That function? Are you
I'm
saying use
sorry?
that one? Are you saying use that one?
No, I'm saying, for example, like you did,
Uh-huh.
you know, 48,000. So in order to find the function for it, like you said, the 5,200 was in between, fall in between the 6,000. So with the 48,000, would that fall? I'm just trying to get an understanding
Yeah,
of
yeah.
how,
Yeah, I'm
so
just
it
gonna let you
would,
explain it. Because it sounds
that
like
would,
you're saying the right thing. Yeah, it falls
huh?
in between, yeah, it falls in between 26 and 63. That's right.
Okay, so do I just choose on the left-hand side which one to actually use as a solution to finalizing the solution, or do I do the one that's closest to 48,000?
So I'm not sure what you mean by closest versus
You know,
hand side, because this is the thing
yeah,
that
yeah,
over
yeah.
here.
That's what I'm trying to see. Yeah, because the 48,000 is closer like to 50,000, which is closer to the 63,000, right? So we use a solution to solve the equation that's on the left-hand side that you circled part of it, right?
Okay,
So that is that.
So this is an X value, right? So I figure out it's in between these two numbers. And so now I'm like using this function, like you said.
Yes.
So I'm using this function of what, 36, 37, 50 plus, and I'm doing 0.27 times
48,000 minus 26,250.
exactly. Yep, that's it.
Okay, that's exactly what I was trying. I'm
I'm running out of
probably
room
kind
here.
of kooky with trying to explain what I was trying to say, but okay, cool. That's what I.
And did anybody do this?
Excuse me, teacher,
That
please,
should-
can you take a look for the number 2? I wanna just, if just for 1-2 minutes. Please.
Finish this one first.
Okay, yeah, let's finish this one right quick.
Okay, we did, okay.
So
Sorry.
this is what, 48,000,
I had got
26.
I got 9509 and
9,510.
Okay, so I'm getting something like as to text. This legible one here, 36. No, it doesn't work. Well, now it's sharing. I don't know why it does that. Okay.
Can you put the screen back up again so I can take a picture of it?
My device is messing up. So it's not wanting to share right now. I don't know why it keeps doing that. All right, I'm gonna have to do it on my computer. Shift it around right quick. Sorry about that.
No worries.
There we go. That's the one we're on. Okay, so we're doing this. We're plugging it in. We figured out it's in there. So now we're plugging it into this function to figure out what T of what 48,000 is. So I'm doing T of what 48,000. Make sure I got the right number of zeros in there. 36, 37, 50. And I'm adding what 0.27. Let's expand this out so it writes. And I'm doing that times 48,000 minus 26,250. And so I'm getting the same thing. So I think the next thing I'm going to do is probably crunch these two numbers in here. And they're going to give me what, 21,750, something like that. And I'm going to multiply that by what, 0.27. So these are things hopefully you have got enough practice with to do like some order of operations at this point. 58,7250.
Is the number on the second line supposed to be 2,750 or 21,750?
$48,000 minus 26,250. It should be 21,750.
Okay, thank you. I believe you said 2750, so I just wanted to make sure.
Oh. And we add what, 3750. Did not do that right. And that should be what, 9510, 9510. And so maybe throw a money sign on there since we're talking about taxes.
Do you want it in the whole dollar? Because when I calculated it, I actually got 95.09 and 70 cents.
It shouldn't be giving you a decimal.
I got 95.10.
Let's see, 26,250. Did I do this right?
I got what you got.
Yeah, I got 95.10.
Yeah, it should be even.
All right.
But
Or something. 48,000, 26.
is that what they got in the back? Go check. Is that what they said? 95.10. That's it. 520. That's it. Whee. I got too excited. He starts honking when he gets excited. It's got some kind of respiratory thing, I think.
You know, my Chihuahua does the same thing. I think it's allergies. I think it's allergies or something. Because
it has to do with small breeds. A lot of small breeds get it. It's like what they call a reverse sneeze is what I've heard them refer to it as.
Oh.
It's like it's a respiratory thing because like their
God.
noses aren't built. So like
Please don't tell me that.
Especially
my
like
baby.
like pugs I know have it like really bad.
I have a Chihuahua though.
Let's see.
Okay.
Oh.
All right, so 7, did we get around to 7? Do y'all need a little more time with 7 maybe?
Yes, please. Can we have more time?
Yeah, because those are pretty good. What do I say? Amount of work, huh? We got to know how to do some systems of equations. Substitution or elimination. So I think like the first one almost looks like it's ready for elimination or yeah, elimination. That's how I would probably do that one. All right, so I'm gonna give y'all, I don't know what, 10 minutes or so to get through 7. If you get through that, start looking at 8. That's the next one we're gonna go to, I think, is 8, 7, and 8. All right, so let me open up the rooms.
Please, teacher, can you take a look for the number 2?
Number 2, what is that?
Please,
Tables,
it's
listen
like
to
the years.
Okay, so if they want the rate of change, what is the rate of change?
The rate of change, it's like the revenue by years.
Yeah, what do we also call that?
It's the slope.
It's the slope. So it's
Because they're giving the year for 1994, and I pick up 2 points like the 1997 and 1995. Is it the same thing, or I'm not sure about what I did?
So part A asks about the rate of change. So if we're looking here, I believe these are each going up by 3, and
3
these are
over
each
2.
going up by 2.
Yeah, it's 3
And
over
so
2.
yeah, they're basically asking for your slope, which is the
3
3
over
over the
2.
2. And they want to find a formula for the revenue. This is another one of those things. They're doing years since 95, I believe, right?
Yes.
And so
They
they're
have-
gonna do, if we want to
Like we
find the
need to pick
formula,
up 2 points in the table, right?
if we want to do the formula, we need to know the slope and we need to know the intercept. And so we
Right.
just found the slope was and just
3 over 2.
3 over 2. And so that's the thing that's attached to the x. And the intercept is what, 33.6?
Yes, because I think I just put the points.
But
Yeah.
if we're doing years since 1995, we don't want our x to be just x. It's going to be x minus the 1995 to count for the fact that we're starting in 1995.
You mean we need to like 1995 minus 1994?
Is it starting in 1995? Is that what it say? Yeah, we're starting in
Yes.
1995. And then we're going to estimate 1994. So we're going to plug in 1994 into this equation, into the x.
Okay, okay. But when I uploaded it from
And so I think that gives you a -1, right? And so -3/2 minus 1.5. What was that? 32.1, I think is what it is. And it says interpret the rate of change. So 3/2 is 1.5. So this is going up $1.5 billion for every 1 year, I think is what that means.
Okay, thank you.
Change in Y over change in X.
Thanks so much, teacher. I appreciate
These solutions are also on this paper afterwards, after all the problems, basically. So we're not trying to hide solutions from you. That's for sure. Not until the test, maybe, right? But we'll give you all the solutions you want. Math ain't about the solutions. You got to know how to do the process.
Yeah.
Okay, so any questions before we go to groups? So 7 and 8, we're finishing off 7 systems of equations, and then we're going to jump into some word problems. Okay, I'm going to open up
I was
groups.
just
Someone asked something?
Part A.
Which one?
Sorry, for number 7, part A.
Problem when you did plus 4y, I mean plus y to get y on the other side and did the minus 1 to get the 1 on the other side. You did it that way because y didn't have nothing on it, like y didn't have a number on it.
Yeah, it was by itself. Yeah, and so it just has basically a 1 coefficient. And it's easy to solve for things that have 1 coefficient, basically.
Okay, gotcha.
You could absolutely do it the other way in this one. This one is like, it's probably equally as difficult either way. If I wanted to, I think I could have just multiplied 2 times everything in this first one
Yeah.
to do elimination. That's also another way you could do it. You'll end up getting some nonsense. It may not be -2 and 3, but it'll be some other 2 numbers that aren't equal to each other. There's a lot of numbers out there that aren't equal to each other. So B is no solution. Questions about this one? Okay. Got 2 more. It's around Sage. Trick on you yet? Or Kayla? Okay. Anthony, are you here? What are y'all doing? I'm not on mute. Okay.
Maybe we need to take attendance again if half of them are dipping out early.
Yeah, I don't know. I mean, they got the test, not me. I'm here for your benefit, man. Like, I don't know like what y'all are doing, but like,
I don't know what I did quite wrong on these. I feel like I'm doing the wrong way or something wrong because every single time my X or Y would be a fraction. When doing this, like for example, for D, for my X, I got -39/7, which
yeah,
I wouldn't be able to
I don't
plug
want to
back
say
in.
it can't. I don't want to say it can't ever be a fraction like that.
Well, yeah, but I mean, I
But
can't exactly, for these problems, it doesn't look like it's supposed to be.
yeah, we're probably not going to give you something that weird unless it's just a word problem and it's like about reality.
Yeah.
Yeah, we're trying to test on the concept, not on whether you can do weird numbers.
I
So,
did substitution on this one.
Yeah, how did you do substitution on this one? What variable you
I
gonna
don't-
solve for?
think I did do substitution. Which one?
C?
Which
C.
C? I actually just kind of pushed over that one, tried to do D to test my theory. But what I've been doing is just trying to I times the whole equation to make the Y variables the same. And then I sort of subtract from there.
That's elimination.
It's elimination. Okay.
Substitutions when we solve for a specific variable.
Okay.
So who said elimination?
I said substitution.
Substitution.
I don't know. So
Do you want to do this one?
I can, yeah. I moved the 4, so it can be y equals 3x minus 4.
Yeah, so we start with, ooh, that's horribly not drawn in the center of that. But we start with this equation. And so we move things around. So I think we'll get y. We're going to move that 4 over. And so we get what? 3x minus 4.
Yeah, and then plug that into the second equation.
So I know everywhere where I have a y, I can plug in a 3x minus 4. So here's where I have a y. So I want to take this equation, which is a minus 6x plus what? 2y equals a minus 8. But I don't want y in there anymore. I want the thing that's called 3x minus 4.
So, 6x minus 8, which is -8.
Okay.
Are you doing D, teacher?
I'm doing C right now.
C, okay.
And then, well, your negative 6x and positive 6x, that cancels out. So it's -8 equals -8.
What does this tell me?
Infinite solution.
The dependent or something like that, right?
They're dependent. How many solutions do I have?
No solutions.
So it will go on and on, right?
It's
Yeah.
an
Yeah,
infinite
the-
solution.
Oh, infinite.
Infinite many. or-
Infinitely many solutions. Yeah,
Infinite number of solution.
yeah. And then the notation is like we have an X, and that X has to follow a rule. You can throw in basically any one of those equations. It should follow one of these rules, right? It should look like something that's on the line. Ooh, not an X, X and a Y. Sorry. It should be an ordered pair.
Like teacher here, we need to be specified, right? To say if it's dependent or independent or whatever, right?
I'm looking for infinitely many solutions, and you should probably tell me like it looks like an ordered pair that's on this line. And this, I was really trying to get you kind of geared up to the next thing, which is the matrices, right? And how their solutions look. Okay, last one, D. How'd y'all do D? Did y'all do D?
Well, I got that fraction, but you said that was because I used elimination, not substitution, or the other way around.
You should be able to do it either way. It should work.
You
Oh, I
could-
got fractions for D2.
Let's see. It might be fractions. I might be wrong. I hadn't looked at the solutions, if I'm being quite honest.
I haven't done D, but I do elimination.
Sorry if I'm kind of interrupting, but I did want to clarify something. So I guess, is there a way to know if we're supposed to do elimination or substitution, or?
It's whichever one looks easier, basically.
Yeah.
So like, if I clear all this real quick, if I'm looking at the first one, we did elimination because like these things were set up right here with the same number, basically. We just had to multiply by a negative to change some opposite signs. This
Okay,
one,
so basically, if you have that number where, you know, one's negative already set up, one's positive, then you get rid of it, you do elimination. And then otherwise you would do substitution?
it's just if it seems easier, go for it. It's kind of, you just have to kind of look at them and see, is it easier to find a number that I can eliminate, or is it easier just to solve for like a single variable?
Gotcha, okay, I was just making sure, I wasn't sure if there was like a specific method for that, okay.
No, they're both valid methods. You can use either one. It's just whichever one seems easier with the problem. You just kind of have to look at the problem and see, does it look like I can match them up and eliminate them, or does it have a single variable out there I can pick on and get it by himself?
Okay, sure.
So, I'm sorry, with the, like, number D, using, the elimination, elimination? Yeah, so, how we're supposed to, like, for this big one right here, number D, let me see how I can say this. So we're supposed to use the greatest common fast, the GCF, right?
Yeah, so I was gonna walk through it with Brian since he was asking about it.
Okay, I'm sorry.
Yeah,
Premature.
you're fine.
I'm sorry.
So what did you multiply by?
So I went to, what, on D, I went to 10, So
For the y, is that what you're doing?
Yes.
Okay, so if you're doing making the y 10, so
I
you're looking
multiplied the
at
first
either
equation by 5 and the
looking at-
second by 2.
you're looking at either 3 and 4, or you're looking at 2 and 5. So what he went with was 2 and 5, and he wants to multiply them to 10. And so the top one, I'm guessing you multiplied by what the number 5,
Yes.
and the bottom one by 2.
Yes.
No, by -2 to eliminate one of them because minus
So one of them
Hold on.
should be minus.
should
So
be negative.
what did you do? One of them minus, or did you just make them both?
I
Positive?
did not. I made them both positive.
For this
Okay.
one, you can
I'm gonna
find
do
your
one of them minus, just because that's the way we're doing it in the book and everywhere else in the notes. But it should still be the same. If you just did that and then you did subtraction, your numbers should still match up. They're just gonna be off by a factor of like a negative.
Okay.
So if I rewrite these, this is what 15x minus what 10y.
Equals
Equals
negative
7.
35.
Yeah, negative 35.
Oh, my
everything's gonna get multiplied. Minus 4 and a minus 2 is what, an 8x?
All right, quick question. So you multiply the entire equation by 5?
Yes, every number gets
Yes.
multiplied. Everything gets multiplied. Each term.
Oh, okay, that makes more sense. Thank you.
We're multiplying it by the left side, so we have to do some distribution because there's multiple terms there. And everything here by a -2, so that's a +8. This becomes a what? A +10. And this becomes a minus.
-4.
And now we're doing that elimination step.
Mhm.
So then it would turn into 7x,
It should be
10y.
should be 15 minus a -8, right? On your paper.
Yes, 15 plus 8.
It should be that should be the thing that combines to
Yep. Okay. Yeah.
23.
No. I had a 15 minus a -8, so I got 7x. Yep.
That's why I suggest multiplying through by that negative, because then you're just adding things. It's a lot easier to add. You don't have to account for that negative in your head. Tend to mess things up a little less. This might be nasty fraction.
Mm,
Is it? Yeah. Because we're getting what, like -39 over 23? Is that right?
Yeah.
Nice
Turns out
score. Okay. Yeah, that's not it doesn't simplify or reduce. They're both prime, right? 23x equals what, -39? X is what, -39 over 23? Is that right? Anybody check?
That's what I got too. 5, 10, 15.
Yeah, that's it. They gave us weird fractions. Okay.
But then
It could be.
in that case, would you try to simplify it or keep it as is?
That's as simplified as it's gonna get because they're 23 is prime.
Gotcha. Yep.
And also, can we put it in a decimal in order to find
would-
out what y is?
I would not put it in a decimal. I would keep it that number.
Oh, Jesus.
Yeah, that's nasty. I'm not gonna give you numbers like that on the test for sure. So we go plug this back in. I'm probably gonna use my calculator to do it. I don't want to waste time like crunching numbers in class, if I'm being honest. It's not worth it with the time we have left here. And y is the number, whatever they get in their solution. That's a nasty number, but it's doable.
I don't believe of this solution, teacher. I think we did some mistakes somewhere in the account. I
That's
don't think so.
correct.
It's 39, 20. but
Yeah, it's a
20.
nasty number. It's -39 over 23.
Yeah.
3 times what? -3 times 39 over 23. And then I'm going to add that to a -7, and then I'm going to divide that by a -2. Jeez.
But the most important feature is like the method how we solve it, right?
Yeah, those are not pretty numbers. I don't know why they throw such nasty stuff at you on the review.
Okay.
Was that 22 over 23?
I wanna do it.
So we go plug it back in, we should get 22 over 23. Okay. Did anybody get to 8 or look at 8?
I did.
Ooh. All right, so let's read it right quick. I feel like give you a few minutes to do it, right? There were 200 tickets sold at a volleyball game. Tickets for students were $2 each. Adults were $3 each. The total amount collected was $530. How many of each type ticket were sold? So we want to write systems of equations. We want to write things as variables. So the first thing I should do is define my variables. So what did you let your variables be?
I put x plus y equals 200. And then the next equation was 2x plus 3y equals 530.
So x and y is what you're telling me.
Yes.
Yeah, it's x is the number of children and y is the number of adults.
Number of child tickets sold.
Like let's x equals the, which is the students, and the y is the adult.
All right, so X is the number of child tickets sold, Y is the number of adult tickets sold. And so this first bit of information, they say there were 200 tickets sold at a volleyball game. So if we want to account for all the tickets sold, I believe that's the X plus Y that you're talking about. And that's going to be a total of
200.
200. And then you told me something, so that's the total number of tickets. The other thing that we want to talk about is the cost of this. So if we're talking about the cost of this, it's what, $2 per child. So if I want to know how much all the children spent, it's the amount they spent times the number of children. If I want to know how much the adults spent, they spent what, $3? And there were Y adults. So if I want to know how much total the adults spent, it's the price per ticket times the number of tickets you sold. And we put those two together, we should get what?
Two equation with two variables.
The 530 total amount collected.
Mhm. Teacher, here it's the 2x plus 3y, which is the 350, right? Yes.
530 is what it is. That's it.
530, it's not 5. Yeah, okay, 530.
Okay. And then we have two systems. We have a system of equations. This is the thing that we're doing before, right? So I'm going to go maybe a little faster. But if I were doing this, I would probably just do what? -2 times the top. I think that's the easiest way to do it. -2x minus 2y.
Equals to
What, minus
minus
400. You add it down. I think we're getting what? Y is equal to 130. Is that right? Should be able to solve it from there.
Wait, sorry, how did you get, wait, how did you get that? The negative 400?
Multiply the top by -200. I mean, -2.
Yeah, distributing that -2 to that top equation.
Oh,
We're doing
gotcha.
elimination.
And that should give you your Y variable.
And sorry, how did you get the -2 that you're multiplying it by?
Just trying to look along here. Trying to do the elimination with these two numbers.
Oh, so you moved it over? Okay, okay, I think I get it now, thank you. It's hard to see with the color too, but okay.
Yeah, it's crashing into that background there.
But when you have a oh,
yes.
Never mind. I have my upside down, I guess, because the way that I was looking at it was is going to be just y, whatever it is. I'm sorry, I looked at it wrong. I apologize.
All right, so I want to get through 11, 12, and 13. I want to give y'all a little bit of time to do them on your own. I don't really think we have enough time to like open up groups, if I'm being honest. I just want to give y'all a few minutes. Look at 11, 12, and 13. Mostly 11 and 12, getting those set up.
So just kind of looking at them, not really trying to solve yet, or?
I'm going to basically kind of set them up, I think is what's going to end up happening, because we don't have a whole lot of time left. But I'm going to give you the setup to be able to solve them.
Okay.
So I would try to get them set up, I guess.
So which numbers did you say?
11 and 12.
11, 12, okay.
Minutes left.
So what should you probably draw for number 11?
The box with the D equals R times time. I mean R times T.
Oh, that
Right.
sounds great.
Okay. See, I know that part. Thank you, Lord.
If you can get that part and you can get some of that information in there, you'll at least get some points, most likely.
I had a question about that.
Number
So
11.
would you multiply it by 4? I'm sorry, would you make the box, how many boxes would you make?
Okay. Draw it out. Should be distance equals rate times time. And so I think we have two different people here that we're accounting for.
Yeah.
The husband and the wife. Whatever. Okay. Felicia, whatever. And her husband.
Felicia and husband. Okay. Now I want y'all, like, if you're not reading this problem and trying to do this, I don't know, you're wasting your time. Because we're getting tested over this pretty soon.
Here we need to solve for X and Y, teacher, right?
It depends how you set up your variables.
So would you put in the 55 miles per hour
For who? Who's doing that?
as the rate, I think? Or would that be the distance?
Whose rate? Is it Felicia's or the husband's?
The husband,
So the husband was driving 55.
mhm. Okay, because I got that there.
How fast was Felicia driving? Does it say?
45.
45.
Oh, that's the 45.
Okay, got that there.
What do we want to know? What are they asking?
How long it'll take for them to catch up?
Very
How long
long.
it will take? They're asking how long is a time
Yeah.
question, right? So we want to know time. So we probably wanted to have like some variable. I'm probably going to do t equals time.
It's the time. Okay.
Time for,
Time minus 3
do we want to do the husband's time or we want to do Felicia's time is the question now.
husband's time, please.
We want to do the time for the husband. So if that's true, then this one is T.
Mhm.
And if the husband was on the road for T hours, how long was Felicia on the road? Now this is the tricky part.
2 plus
Plus 20 minutes.
T plus
or
3
1/3.
hours.
20?
What's it? No.
We got to be careful on this one.
Yeah, I thought he left 20 minutes in an hour and 30, 1/3 hour later. Because he had to wait for the dog sitter, right?
It should be T plus 1/3.
Yeah, we got to keep the same units. So if we're doing miles per hour in our rates, we have to keep these the same units. So this should be the 1/3 hour. I know they're giving 20 minutes versus 1/3. You should be using the 1/3 hours here. And part of that's because they're giving us in miles per hour, we have to plug into hours. And then we're thinking, is this plus a third or minus a third is the next thing, right? It's like, is it plus or minus? Is Felicia on the road longer or shorter than her husband?
Longer than her husband.
She's on the road longer.
Yeah,
She
it
left
should be a
earlier.
plus.
That is the one that usually confuses people, I feel like. So it's plus or minus. All right, and we're almost done at this table. We just got like one little more spot. And then we just
40, the 40, or
yeah, I'm like, what am I putting over here in my distance? How do I figure that out?
with Felicia's rate.
With rate times time, right? Is how I figured this thing out. I'm doing rate times time. So if I'm looking, I think husbands is easier to figure out, right? If I look at my husband, I'm doing my rate times my time. My 55 times my T.
55 times minus 1/3 equals to 45 T.
And this one. So what is Felicia's rate? If her husband is 55 T, Felicia's rate is
45
45 times.
parentheses T plus 1/3.
No.
yeah. Are you doing T minus 1/3 for the husband? Is that what you're doing?
Yes, I did for the husband.
Okay. So then you're finding Felicia's time.
Oh, okay.
The way you have your table set up. You'll still find it. You'll just have to do a little bit of wiggling to get back to the husband's time.
Okay. Sorry. Thank you.
Because I think you let T be Felicia's time. You have to do T minus 1/3. You can do that.
For husband.
But then you're finding Felicia's time. It still works. It gives you both the times. You just have to go back and look at how you defined your variables. All right, and so if I want an equation to solve this thing, and we're getting right that time, what's my equation to solve this thing?
45.
We basically know that their distance has to be what?
Have to equal.
Equals the first one equals
They
the
have to be
second
equal.
one.
If they're catching up to each other, that means they're at the same distance. So we set
Yeah.
these two things equal to each other, and we solve for
T.
whatever the heck T is, right? That's going to be her husband's time.
Okay. Yeah.
All right, so I think I'm going to go over maybe like the setup for 12 right quick. It is really similar to 8, except they turn it up like one notch, but it is right at time. If you got to go somewhere, that's fine, I understand. But this will be recorded. Hopefully I am recording it, yeah. All right, so how do we set up 12? 20,000 to invest. She hopes to earn 1390. She wants to invest in treasury bills to be 3,000 more than she invested in corporate bonds. Expected returns, they give us the returns. And then they say, how much should she invest in each one?
For the first one, I just put A and B as my variables. A plus B equals 20,000.
A, B, and what'd you do? Did you do a third variable?
No.
Ooh, there's
the
three
first equation.
accounts. Yeah,
There's two accounts.
There's three accounts here. There's treasury bills, treasury bonds, and corporate bonds.
Oh, it didn't say that in there. It just said that she wants her investment in treasury bills to be 3,000 more than her investment in corporate bonds. It didn't say anything about treasury bonds.
And this one, yeah, you could use just A and B. So I'm trying to define my variables first. So I like this. A is the amount in
Treasury bills.
treasury bill. B is the same what? Amount in
Corporate bonds.
I would do that with the treasury bond. I would do like C is the amount in corporate bonds.
Are you just saying, are you saying that there's three accounts just because there's another variable with the percentage on the bottom?
Yeah, it says she's hoping to.
Okay, I thought it was a trick question and that there was three there and.
Yeah,
in
she's
the
going to
wording.
invest in three accounts. Is the way I'm reading this.
Oh, okay.
And I think the instructions for this might be a little bit misleading when I read functions of two variables and systems. No, this has three variables. So I don't know why they say two variables. This obviously has three. But it's something we did.
And the rest of my setup's all wrong, so.
That's fine. But like what'd you do for the first one? You took the accounts and you did what?
I just did, I thought there was two, so I put A plus B equals 20,000.
Yeah, so A plus B. If there's a third one, now we're adding
C.
Plus X.
B 20,000. That's it. And she wants her
And then-
investment in treasury bills, which is A, to be 3,000 more than her investment in corporate bonds. So this is something that's maybe a little bit tricky because we're talking about treasury bills, which is A, and we're talking about corporate bonds, which is C. And I know I have to add 3,000, but which one am I adding 3,000 to?
3,000 A.
The A, right? Hold up.
So the
Okay, I'm adding
treasury bill, this one
B?
should be more. She wants this one to be
Oh,
3,000.
the treasury bill.
It's
You mean 3,000 in her, you mean 3,000 in her B, in her corporate.
If
So
we
it's
say
3,000 B.
If we just write out the sentence 3,000 more than corporate bonds, what does that look like?
A equals 3,000 C.
Yeah, that 3,000 should be getting added to the C. So I'm glad we said it. Because a lot of people are thinking the same thing. But we should be adding that 3,000. We're saying that the A is more, which means we should be adding the 3,000 to the C. The expected return. So how do I find out the expected return? I know treasury bills are 5%. So how much do I earn in treasury bills? How do I figure that out?
5% times A, because that's what's in the treasury bonds.
Yeah, exactly. Yeah. So I know it's 5%. 5% of what? It's 5% of whatever the heck the amount is in A. I know the next one is 7%. So maybe we have to convert these two decimals correctly, right? But that's 7% of whatever the heck is in.
B.
Excuse me, are you writing in the board or?
Yeah,
I
it
don't
should
know
be.
where you're writing.
It should be up here. Am I sharing it?
Yes.
Can y'all see it? Okay.
I see it.
Okay, thank you.
And this is equal to that number they gave us.
3,000?
The problem. The 3,000 was all the counts together, right?
oh.
Or
1390.
or that second, yeah, 1390 is the number that they give us for the earnings on this in interest.
Okay.
These are our three equations. How would you solve this? Very carefully.
Jordan. As the matrix.
Yeah, with the matrix.
Matrix, yeah.
So maybe a little bit of rearranging on like this guy, right? To put him in the matrix form. I believe we have to do like A plus 0B. 0B plus 0C plus no, minus C. So we do subtract the C over. So you might have to subtract the C over to put it in standard notation to get it into your matrix. But the rest of them should be there, like ready to put into the matrix. These are all ones, 1, 1, 1, 2, 20,000. Doing 1, 0, minus 1, 3,000. I'm doing these decimals and then 1390. Okay. Any questions?
Okay, and after we put it in the matrix, and the answer will be what we got out the matrix, correct?
Yeah, so the matrix should just basically be giving you the solution like in order, right? A, B, C.
Yeah,
Yeah, that's it.
trying to double check.
Any questions? I think we're gonna hit stop on the record unless they've got more good questions.
What was the answer for 13, 12?
12? Oh, I hadn't done it yet.
Oh, okay.
I'm gonna do it in a matrix right quick. It's a 3x4 matrix. It looks like 1, 1, 1, 20,000. 1, 0, minus 1, 3,000, and 0.05, 0.07.
So I do have a question. So regarding elimination,
Okay.
How do we know when we're supposed to use the Gaussian method and solve it by hand versus using our calculators and technology?
On the test, we wrote very clearly showing work by hand, not using technology. You can still, of course, use the calculator to check your answers.
Then how would you solve this one without a calculator?
yeah, exactly. That's what I was getting at.
I made the test to where you probably shouldn't need a calculator for the matrices. If you wanted to check your solution for the one you're doing by hand, you might want to use it for that. I don't want to say too much because I don't want to tell you what's exactly on your test.
But for like this one, if there's something like this on the test, we have to show our written work.
No, the problem that you have to show your written work says on it, and it's not as hard as
Okay.
it, because there's no decimals necessarily. It says on it, show work by hand, not only with technology.
Okay, okay.
Okay. That's,
Yeah, okay. I just wanted to make sure about that. That makes sense.
And I got like 8,000, 7,000, 5,000, I think is what I'm getting for this one. When I plug into my calculator, I get the, the good old arrangement, echelon formation there.
Which one is that one for?
This is the one we just did, number 12. When I plug that matrix into my calculator and do the row reduced form. Something like that. That means there's 8,000 in the treasury bill, 7,000 in the treasury bond, 5,000 in the corporate bonds. And they had to name those accounts as similar as possible just to really confuse you, I think.
I have to be careful with that one. Okay.
Got to distinguish your bills from your bonds, the treasury from the corporate.
For me, the word problems are the most challenging ones. So anytime that it's a word problem, it trips me up. They're not my favorite.
That's usually pretty consistent reviews.
But for 13A or even B, that we'll have to do the matrix for that, right?
Yeah, so these you should be able to do by hand.
And by calculate, I got that. I love the matrix. I understand it. Everything else is just like, but I'm gonna give it my all. I understand how to do the matrix.
Yeah, I'm with you on that. I'm just gonna try my best and see what happens. Hopefully not leave anything empty.
But no, but yeah, and I just need to go over like questions for like we had like 6 and 7. But I have a tutor today at 2:30, so I will talk to y'all later.
All right. Good luck.
Thank
Okay,
you.
thanks everybody. Have a good day.
Good luck.
Bye, thank you.
Thank you.
For 6.5, I know there wasn't like an actual like homework because we did everything in class. Do we just submit that?
Yeah,
Okay, all right.
there's not going to be a graded problem. Just be basic completion work for that one.
Okay, and then well, corrections, 6.4B would also be due today, right? Okay,
6
thank you. You'll have a good day.
You too.
This is 6.4 is due today.
6.4 B corrections are due
Correction.
tonight, and then 6.5 is due tonight, and there was no graded problem on 6.5.
6.5 B.
Yeah, there's no graded problem on there. It was only the textbook stuff that we did in class.
Oh, okay. Am I the only one in here? Everybody's cut out.